In this tutorial, we're going to look at vectors and how they relate to geometry and indeed geometrical shapes. So before we create shapes, let's just go back and just create a couple of vectors. I'm going to create a vector A, which will start from here, and it will go along 5 and up 2. 5 along and 2 up. And the blue line here is the resultant journey. Let's do the same for vector B. Horizontal journey of 1 and a vertical journey of 3. And again, vector B will form. Now both vector A and B don't have to start from the positions we've set here. I can move vector A's starting point around to be anywhere I like. It's still vector A. Equally, vector B, I can move it around wherever I like. So let's join vector A to vector B. And now if I want to do a journey right from the start of vector B and end up at the end of vector A, my journey would be this vector. And its horizontal journey is just the simple addition of the horizontal journey of vector A and then vector B. So it's 1, 2, 3, 4, 5, yes, 6. 1 plus 5 is 6. And its total vertical journey, 1, 2, 3, and then a further 2. So look, let's clear the decks and see how vectors completely link with geometrical shapes that we know already. So what are we left with? We're left with vector A, which is defined as a long 5 up 2, and vector B, which I've now turned red, a long 1 up 3. So if I was to draw another vector A from this point here, I'd have to obey the rules of a long 5 up 2. So a long 5, 1, 2, 3, 4, 5, and up 2. And that's another vector A. And now suppose if I draw another vector B starting from this point here. I'd have to obey the rules of a long 1 and up 3. And you can see we've formed a parallelogram. Both vector B's, by their definition, have to be parallel with each other. A long 1 up 3, a long 1 up 3. And indeed vector A, obeying the rules of a long 5 up 2, a long 5 up 2, are also parallel with each other. The arrows, remember, are important. Vector B can only travel along in a positive direction of 1 and up in a positive direction of 3. So let's see if we can work out the definitions of the two vectors, one of which goes along that diagonal and the other one from that corner to that corner. So let's first of all have a look at this journey here. Let's give it a name. It's vector C. To do its journey and go along lines we already know the definition of, I'd have to go along vector A and then up vector B. And as we can go along the positive directions of A and B, as a vector equation, I can write that C is equal to A plus B. So let's express A and B as column vectors. I can say, well, A is the column vector 5, 2, and B, again as a column vector, 1, 3. And if we add those using our rule of the top row and the bottom row, 5 plus 1, 6, and the bottom row, 2 plus 3, 5. Let's check. Vector C is a horizontal journey of 1, 2, 3, 4, 5, 6. Yes, that's correct. And a vertical journey of 1, 2, 3, 4, 5. Vector C, 6, 5. But what about this vector? Before we start, let's give it a name. Let's call this vector D. And it is a journey from this point to this point. So how can we do that going along the red and blue lines that we know definitions for? Well, we would have to go down this vector and up this vector. Going down this vector, we're disobeying the arrow. We're going the wrong way up a one-way street. So if I am to travel along that vector, I have to call that negative B. We're okay here because we're going along with the traffic along the one-way system this way. So I can say that vector D is equal to, well, let's start our journey, negative B plus positive A. And that's equal to, well, negative B as a column vector is negative 1, negative 3, plus A now normally as a column vector, 5, 2. Adding the top rows, we get 4. Adding the bottom rows, we get negative 1. Is that in fact the case? Here's our journey again. Yes, we have to drop down 1 and go along 1, 2, 3, 4. So we're correct. So vector D can be defined as a column vector for negative 1. But there's a second option for vector D. We could have gone along this vector and then this vector. The result's the same. So we can choose to go on our vector D journey by either going down the bottom of the parallelogram, minus B plus A, or the top bit of the parallelogram, and you just do it in a different order. This is positive A minus B. Okay, I've changed the diagram a little bit now, and I've introduced a point M, which I'm defining as halfway along vector A. And let's see if we can work out the journey from this point here to M. So let's give this journey a name. Let's call it vector P. To make the journey of vector P, I can go up the correct way along vector B, but I only want to go half the way along vector A. So my journey vector P can be defined as the whole of vector B plus, and I'm going along the right way along vector A, but I only want half of it, half of vector A. Okay, now in column vector terms, vector B, our old friend 1, 3. Plus a half of 5, 2. Okay, that's equal to, and let's just tidy this up, that's 1, 3, unchanged, plus a half of both of these values here. So this is 2.5 and a half of 2, 1. Now we can add them up. 1 plus 2.5 is 3.5, and 1 plus 3, 4. Let's see whether it's true. Let's do the horizontal journey first. 1, 2, 3 and a half. Yep, okay. And the vertical journey, 1, 2, 3, 4. So it's correct. Vector P can be defined as 3.54. So for our last journey in this tutorial, I've introduced another point, and this is point N, and again I'm defining it as halfway along this vector A here. So what about the journey from M to N? I think you can probably guess the answer, but let's prove it. Okay, so we're starting here. We're going to go halfway along A in a positive direction. Then we're going to go along B in a negative direction, and then backwards along another vector A in a negative direction. So let's give this vector a name. Let's call it vector R. Okay, let's describe its journey. Okay, first of all, we want half of vector A going in a positive direction. Now we're going against the red line, which is vector B, so we take away vector B. And now we're going to go against vector A's definition, but we only need half of it. So we take away a half of vector A. Well, hopefully you can see this term and this term cancel each other out. And what are we left with? Well, we're left with just negative vector B, which if you look at the diagram is correct. Vector B is defined as a long one up 3. Well, what are we doing here? We're going back 1, down 3. So we've created another vector B, but in the reverse direction.